What is the mystery behind the zeroth root? Let us start with the basics. What is a root? Someone from biology might joke that a root is a part of a plant, but in mathematics, a root answers a simple question. For example, the square root of 4 asks which number, when squared, gives 4. The answer is 2. So the square root of 4 is 2. The cube root of 8 is also 2, because 2 multiplied by itself 3 times gives 8. In general, if some number raised to the power n gives another number, then the nth root of that answer, x, gives us the original number a. Now comes the strange part. What happens if the power is 0? We know that any number raised to the 0 power is equal to 1. Like 2 to the 0 is 1, then 3 to the 0 is 1, and so on. Because of this, it feels like the zeroth root makes no sense at all, since many different numbers would give the same result as 1. But instead of giving up, let us look at the idea from another angle. Any root can be rewritten as a fractional power. For example, a cube root is the same as raising a number to the power 1 divided by 3, and a square root is the same as raising a number to the power 1 divided by 2. Following this pattern, a zeroth root would mean raising a number to the power 1 divided by 0. This is exactly where the problem appears, because dividing by 0 is not allowed. That is why teachers strongly warn against this idea. But suppose we do not jump directly to dividing by 0. Instead, imagine slowly decreasing the denominator. For x greater than 1, as the denominator becomes smaller and smaller and approaches 0, the result grows larger and larger, and it seems to shoot off toward infinity. This makes it tempting to say that the zeroth root of a number greater than 1 is infinity. However, this conclusion is still incomplete. The trick is that we assumed the number x was greater than 1. If the number is between 0 and 1, the behavior is completely opposite. In that case, as the denominator decreases, the value shrinks instead of growing. So now we can make a general rule. For numbers greater than 1, the result goes to infinity. For numbers between 0 and 1, it goes to 0, and for 1 itself, the result could be anything. But even this is not the full story. We also have to remember that we can also approach 0 from the negative side. If a negative power appears, everything flips again. What went to infinity now goes to 0, and what went to 0 now goes to infinity. So the situation becomes even more confusing. The final lesson from all of this is simple. Do not torture your brain over things that mathematics itself tells you not to do. If the rules say a concept is not well defined, it is usually better to accept that.